Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever listening to the legendary Cars. Let's go. So let's go right into the Moivre's theorem. All right. So he looks angry, doesn't he? Looks like an angry man in that picture, but we'll leave him alone. All right. So let's take a look at where de Moivre's theorem comes from. If you consider the complex number in polar form of mod z cis theta, and we square that puppy, we end up with mod z squared multiplied by cis theta plus theta. Why is that? Well, recall in properties of cosine isine that if you multiply them, you just add the arguments, you add the angles. So that becomes mod z squared cis 2 theta, and also recall that mod z is also equivalent to r in our world. So if we cube it, looky here, we end up similarly with mod z cubed times cis 3 theta. So hopefully you see the very easy pattern here, which gives us de Moivre, and that is mod z cis theta to the nth power equals mod z to the n times cis n theta for all rational numbers n. And we have that within this formula. Here it is right here. Isn't that nice? So there we go. Actually, we don't have mod z. Do we have this in this form? We do not. I mean, we don't have it in cis theta, but we have it here. And I'm going to be late to the faculty meeting. I don't care. All right. So let's do this, shall we? Oh, there's a proof. I forgot. Never mind. There's the proof. If you want to pause and look through it, I'm not going to take time to do it in here. It's not too horrible. I think you can probably follow it. So we can use de Moivre to find the exact value, meaning we're not going to do a decimal approximation, of the expansion of root 3 plus I to the 8th power. And then we'll check it with a calculator since you people don't believe anything that's not on a screen. So first of all, we're going to take root 3 plus I and write it in polar form. So that means I need R, which is equal to root of root 3 squared plus 1 squared, which I hope you immediately see is equal to 2. Are we good? And then we're going to get to, well, let's do it like this. Root 3 plus I would be equal to 2 times root 3 over 2 plus 1/2 I. And so that's in the form of cosine isine or cis. And I have 3 young men in here who know that if cosine is equal to root 3 over 2, and sine is equal to 1/2, then theta is equal to? Thank you for your enthusiasm, gentlemen. It's equal pi over 6. That's right. The best of the best in the room. So that would be equal to 2 cis pi over 6. Nice. Is he going to come out of the closet? Okay. I'm not sure he's ready either. All right. So now that we're in polar form, boys and girls, we can use our good friend de Moivre to help us out. So root 3, let me move up here. Root 3 plus I to the 8th power would be equivalent to 2 cis pi over 6 to the 8th power. And by de Moivre, that is equivalent to 2 to the 8th cis 8 times pi over 6, or 8 pi over 6. And if this part confuses you, again, remember back to what I said earlier in this video. Properties of cis tell us that if I have cis pi over 6 times cis pi over 6 times cis pi over 6, I just add them all up. And we've already learned that. And so then this becomes 2 to the 8th. And let's see, 8 pi over 6 is equivalent to 4 pi over 3. So you better be thinking what's the cosine and sine of 4 pi over 3. So this becomes 2 to the 8th times negative 1/2 minus root 3 over 2I. which is an exact answer. This is an exact answer here, but we can certainly take it further because we're intelligent human beings. If we take 2 to the 8th and distribute it through, we end up with negative 128 minus 128 root 3 I. And that, my friends, is an exact answer. So what we want to do is show that this is equivalent to root 3 plus I to the 8th power. And I've already done, I can't remember if I got rid of it. I've done them both. Okay, I showed them both here. Negative 128 minus 128 root 3I equals negative 128 minus all this gobbledygook, as does root 3 plus I to the 8th power expanded. I do want to show you that I is located, or one way you can get to I quickly is you hit the pi button here, and there's I, and isn't that great? I equals I. All right, one more example, and we'll leave you alone for the time being. By considering cosine 2 theta plus I sine 2 theta, deduce the double angle formula for cosine 2 theta and for sine 2 theta. This is actually very nice and pretty quick. So we know that cosine 2 theta plus I sine 2 theta, let me fix that n, I sine 2 theta is equal to cis 2 theta, obviously. All right. And then that is equivalent to, are you ready? Are you ready for this, boys and girls? Are you ready for this action? That is equal to cis of theta squared, is it not? Which is equal to cosine theta plus I sine theta squared. And if we expand that, I'll spare you the expansion, but if we expand that and separate the real from the imaginary part of the complex number, we end up with cosine squared theta minus sine squared theta. It's a love story, baby, just say yes. Plus, I mean, you should be able to see this, plus I 2 sine theta cosine theta. So we have our real and our imaginary parts separated quite nicely. And then we're going to equate the imaginary parts because all of this is equal. So if this guy equals this guy, remember, cosine 2 theta must be equal to cosine squared minus sine squared theta. This is a nice little proof. I love it. And if I sine 2 theta is equal to I 2 sine theta cosine theta, then sine 2 theta must clearly be equal to 2 sine theta cosine theta. That is all I have with our good friend Moivre. We'll take it out with the cars and let's go. Hope you enjoyed it. I certainly did. I am out.